That's what I do. How do you do that? What I do is I just graph this to see what the t value is. Cool? But if you want, you can do your what? Quadratic. Let me get this whole thing straightened out here, because I'm just trying to solve this equation, right? What would it be?
1 minus 8t squared.
1.86 t squared minus 15t plus 25 equals 0. Is that everyone agree? Is that a quadratic? Everyone agree I put it all on one side of the equation? Yeah, how do you solve quadratic formula? But everyone, did you know you could pull out your grapher and just graph the thing? I'm gonna do it. I'm upset though I showed this to my pre-calc students how to do this, and then when I put it on the test, they didn't know how to do it. It's not hard. I'm just using my grapher. If you want to do quadratic formula, go ahead. You all know it, right? You've done it so many times in pre-calc. What I'm going to do though, Amber, I'm going to go to my y equals and type this equation, all right? I'm going to type it out. And what's the equation? 1.86x squared minus 15x plus 25. Is it okay I'm using x on my calculator? Yeah, so this is what I put in my grapher. Why? I guess I'm lazy. I like to use technology to solve the quadratic formula. Now, you know what else I'm going to do?
Wait, how did the negative get over to the 15?
I added this on both sides, and then I added this on both sides, and I subtracted 15 on both sides of the equation. Cool? And then when I get this, and I'm going to write another equation, y equals 0. And I'm going to tell my calculator, would you find where these intersect? Where these two things intersect will be the what? The answers. So where's the grapher? Hey, graph. Where's the intersect? I go to second calc. And when it's second trace, and it's called the calc method. Now which one is intersect on that list? Which one's intersect?
5.
Number 5. I'm going to go to 5. First curve, I just hit enter. Second curve, I just hit enter. Guess I just hit enter. And I just found the time. Or I just found out what this answer is. Not to answer the whole problem, everyone, but I know the time. I'm going to solve this. Let me just make a note. The solution is when t equals 2.3534952 seconds. I just didn't feel like doing what formula? What formula?
Quadratic.
Now you may do quadratic formula. I just thought I'd use my graphing, right here, my graphing calculator. This $100 tool to my advantage.
How do you do that second?
Oh, I'll do it with you.
Okay.
You still got a minute. It's easy. You put both of those in the y equals. You go to second trace, the calc menu. What button am I looking for? It's titled what?
Intersect.
The intersect. And I go to it, and when I hit it, Art, it asks 3 questions. I just hit enter, enter, enter. It's going to tell me the answer where these two intersect. Do you get 2.35 something?
No, the second trace.
Yeah.
Then intersect. Then you hit it, enter.
You hit enter, first curve. You go enter, second curve, enter. Oh, it's not going on. I'm going to hit trace just to see if it gets on there. Sometimes I get trace to get it right on there. Did it work? Didn't work on that one? Yeah, I'm going to hit zoom 6 just to zoom in your calculator. All right, second calc, 5. First curve, enter. Second curve, enter. Oh, I know what we should do. Trace, let's put the cursor near it first. Then you'll be fine. Can you see the cursor there? Put the cursor as close. That's good enough. That'll work. It's going to work now. If you put the cursor close to it, I should have said that. Put your cursor close to that in the x-axis and it'll work.
Okay.
Cool? And one more thing, and I'll get your question here, Josephine. I'm getting this for my solution to quadratic formula here, but I used to graph it. What would I do next to solve this whole problem? It says, what is the velocity of the rock at this time? What would be the very last step?
Then you plug in
You plug this in where?
for the
Velocity. That is.
Yep. I plug this into the velocity, and I get, let me see what I get. Ready? 15 minus 3.72 times x. And now when I'm getting about 6.24 meters per second. Cool? Go ahead, Josephine. You sure? Alright, cool. Everyone, great job. I'll see you tomorrow. I'll still go over some problems in this section. Super job today. Amber, Candace? Are you okay with the graph? Did it work? So Art,